Welcome back to Equity Tutors. Today we're going to do our second lesson on gas exchange. Last week we discussed gas exchange in mammals and specifically how the anatomy of the lungs where gas exchange in mammals occurs is adapted for gas exchange and ventilation. So we discussed the structure, the trachea, the bronchus, the bronchioles, the alveoli, and how those structures are adapted to their function, so that we know that the trachea and the bronchus, for example, are more reinforced with cartilage to keep them open. The alveoli are more elastic, so that they can open and close like a balloon. And today we're going to talk about two other structures or pieces of the anatomy of the lungs involved in ventilation that you may not have heard of before. So those are the intercostal muscles and the diaphragm. So the intercostal muscles are the muscles that exist between your ribs, and the diaphragm is essentially a huge muscle existing underneath the ribs that moves up and down as we breathe and actually separates the lungs from the rest of the organs in the body. So before we get into how the process works, let's just talk about breathing to begin with, and the process of breathing and how the air travels into our lungs. So the air, and this is all new information from last week. So the air enters through the nose, along the trachea, the bronchi and the bronchioles, which are structured well adapted to the role in enabling passage of air into the lungs. The gas exchange specifically takes place in the walls of the alveoli, which are tiny sacs filled with air. And as we know, these are specialised for their function by having thin walls. They are they have a good blood supply. They are elastic, etc. All things we discussed last week, and all things which also apply to other gas systems, not just in mammals. So the flow of air in and out of the alveoli is referred to as ventilation. So that is a key term that you need to remember if you ever need to define ventilation. What do I mean by ventilation? So I'm specifically referring to the flow of air in and out of the alveoli. So not the gas exchange, just how the air gets in and out. And this is composed of two stages, inspiration and expiration. So inspiration is when you inhale and expiration is when you exhale. And the process occurs with the help of two sets of muscles that I just referred to, the intercostal muscles and the diaphragm. So I'll refer you first to the first diagram, which actually shows you where those intercostal muscles and the diaphragm are. So the first picture, firstly, you can see this is an image of the left lung surrounded by the rib cage. And you can see the left lung is the greyish structure sitting pretty high in the body. And you can see the intercostal muscles in between the ribs. And then right at the bottom, you can see a much larger single muscle, and that is the diaphragm. And what the image on the left is showing you is inspiration, and what the image on the right is showing you is expiration. But before I go into the details of how that is demonstrated in the images, I want to first describe inspiration and expiration. So during inspiration, the external intercostal muscles contract, whereas the internal muscles relax. As a result, this causes the ribs to raise upwards. So I'll just say that again. The external intercostal muscles contract and the internal muscles relax. That causes the ribs to raise upwards. So you can probably figure out just from breathing in yourself. Now, if you breathe in, you can feel that the ribs raise up. But what you don't know is how that is regulated, and that is by the intercostal muscles. Also, when you do that, when you raise the ribs up, the diaphragm contracts and flattens, and what happens then is that it moves down. What the overall result of this is to increase the volume inside the thorax. So the thorax is referring to all the space essentially in the top half of your body. So what you want to imagine is that you're trying to create as much space in the body as possible for air to come in. Because we know from pressure gradients, which we briefly discussed last week, that when there's more space in one place, that gas will move down the pressure gradient into that space. So what you would do by creating more space in the body is decreasing the pressure, lowering the temperature, creating a pressure gradient, and air will want to move into the space. So the external intercostal muscles contract, internal muscles relax, your ribs move up and out. Simultaneously, your diaphragm moves down. You now have more space in the upper body, more volume, lower pressure. The difference in the pressure between the inside of the lungs and the atmospheric pressure, meaning the air, creates a gradient, thus forcing air into the lungs. And now I'm just going to say that one more time. So the ribs move up and out, the diaphragm moves down. This increases the volume inside the thorax. In combination, the volume inside, so as the volume inside the thorax increases, it lowers the pressure. The difference between the pressure inside the lungs and the atmospheric pressure creates a gradient, thus causing the air to be forced into the lungs. So let's refer back to our image. We can look at either of the first two images I've provided. I've provided two different ones essentially showing the same thing, just so we have a comparison. You can see in the first image on the left with inspiration, the chest is expanding, it's moving out, the diaphragm is moving down. So you can see that the volume in the thorax is larger in the image on the left compared to the right. And you can also see that the intercostal muscles, you can see in the top picture, the external intercostal muscles are the muscles contracting, and on the right for expiration, the internal intercostal muscles contract. And as I said, the purpose of all of this is to create during expiration more volume in the lungs. So let's move on to expiration. So during expiration, what's going to happen, or the aim of expiration is for the opposite to occur. So you want to decrease the volume in the lungs so that you get air forced out. So you may guess that what's going to happen is the opposite contraction to what we saw in inspiration. So here, in terms of the intercostal muscles internally contract, whereas the external muscles relax. This then lowers the rib cage. So again, if you breathe in and breathe out, you'll feel that the ribs will lower themselves down. This is because the external intercostal muscles are relaxing. What also happens is that the diaphragm relaxes, and what happens when the diaphragm relaxes is going to move back up. This does seem contradictory, or it used to seem that way to me anyway. I would always imagine when a muscle contracted that it would become tighter, maybe smaller, and move up, but that's not the case. What I mean by contract is that it is exerting its power. So imagine contraction being as a push instead of a tension. So when it contracts, it's moving down, it's pushing down against the stomach, and then when it relaxes, it kind of flips back up. So when the diaphragm relaxes, it raises back upwards. Now we want to think about what this does to the volume. So everything in the thorax has now got smaller. My diaphragm has moved back up, my ribs have moved back down. The volume inside the thorax has become smaller. What does this do to the pressure? Well, it decreases the volume inside the thorax, therefore increasing the pressure. Therefore, air will move out of the lungs because the relative pressure inside of the lungs is higher than atmospheric pressure. And by atmospheric pressure, I mean the air. So I'll save another recap until the end of the lesson, so I'm not repeating myself too much. But this is one of those things at least that I remember repeating to myself over and over before an exam, but then I really liked it when it came up on an exam because I do find it quite simple. It's a very simple concept, very reliable way to get marks. So I'll save the recap till the end and move on now to the other half of the lesson, which is going to be on spirometers. So if you're with WJEC or CIE, you do not need to learn about spirometers. But for everyone else, so I'll just talk you through firstly what a spirometer is, what it does, what is the point, and then we'll go through over the specifics about what you need to know. Some of you may actually get to use a spirometer yourself, but if not, don't worry, you can still learn everything you need to know from reading about it or listening to this lesson today. You don't need to physically have used the spirometer. So a spirometer is essentially going to measure your breathing. It's going to measure the rate of breathing, how much air you can breathe, etc. So it's a device used to measure lung volume. So I want to talk you through first the structure of a spirometer. So I've included a diagram for you to look at what it looks like. So you can see that there is a girl here, she's wearing a nose clip so that air doesn't come out of the nose, and then she's breathing in and out of a tube. Other parts to be aware of, so you have a trace being drawn at the back, and this is moving as the drum of liquid is moving up and down. So you can see in that central tank attached to the tubes the girl's breathing into, there is water in the tank. And as the water level moves up and down, the trace on the paper being drawn, and we look at some of those traces in a minute, is also moving up and down. So the chamber is also filled with oxygen. That, of course, is how she is breathing. And there's also a canister of soda lime, and that removes any of the carbon dioxide being produced. So essentially what we want to see is the oxygen being used up inside the tank. And that is the reason we want to remove the carbon dioxide, is because we want it to be strictly oxygen use only. So a person using spirometer breathes in and out of the air-type chamber, causing it to move up and down and leaving a trace on a graph which can then be interpreted. And now I want to get into some of the different measurements that can be interpreted from a spirometer. So firstly, we have vital capacity. So this is referring to the maximum volume of air that can be inhaled or exhaled in a single breath. And this is going to vary on a number of factors. So it's going to vary based on fitness, based on gender, age, size and height. So as I said, that is the maximum volume of air that can be inhaled or exhaled in a single breath. And I'll go on to show you what that looks like on a diagram in a second. Second, we have the tidal volume. So this is the volume of the air we breathe in and out at each breath at rest. We then have the breathing rate, might be slightly obvious. So this is the number of breaths per minute, which can be calculated from the spirometer trace by counting the number of peaks or troughs in a minute, not both peaks or troughs. And then the volume of air, which is always present in the lungs, is known as the residual volume. So as you can imagine, when you breathe in and out regularly, not all the air that you breathe is all going to be breathed out every time. There's going to be some left over in the lungs every time you do a breath. So that is called the residual volume. So the tidal volume can be exceeded, such as in cases such as exercise. So you start to breathe more heavily. With inspiration, reserve volumes, that's that air left inside of your lungs, the residual volume. The inspiratory reserve volume is reached in an attempt to increase the amount of air breathed in. Similarly, the expiratory reserve volume is the additional volume of air that can be exhaled on top of the tidal volume. So we've got residual volumes of air in our lungs for breathing in and breathing out. And what you'll see on the spirometer, so if you look at a spirometer, for example, of someone exercising versus their basal rate, and these are common exam questions, is that you'll see that maybe the tidal volume, so the amount of air being breathed in and out, is going to increase towards the vital capacity. So just to recap, the vital capacity is the maximum volume of air that can be inhaled or exhaled in a single breath, whereas the tidal volume is the air we breathe in and out at rest. So the difference between those two is going to be the residual volume. So a question could ask what would take you from your tidal volume to a vital capacity, and for example that could be exercise, where you're then using those extra reserves during exercise to get as much air in and out during that time as possible. So now let's look at an example of what the spirometer readings look like. So let me just start by describing the what's going on in the graph. So we have time on the x-axis. So this is someone breathing into the spirometer, as we just saw in the previous image, and the level is moving up and down as they are breathing in and out. So the lung volume is increasing and decreasing, and you can see that by these little wave shapes. So the tidal volume is this initial breathing rate you can see where the person is at rest. Then you have the vital capacity. So here what's happened is the person breathing into the spirometer has been asked to take a much deeper breath. So instead of the breathing that we are doing now, where we're not really noticing our breathing, we take a deep breath in and out. And what we can feel then is that we're accessing the residual volume. So we get a tidal volume plus the residual volume, which is the vital capacity. And you can see that the lung volume peak increases much more at inhalation, and then it goes again, dips below what we saw tidal volume for the exhalation before returning to tidal volume. The total lung capacity refers to the volume, is the tidal volume plus the vital capacity from where the person has done a forced inhalation, where it peaked right at the top, plus the residual volume from the expiration, which you can see labelled at the bottom. So unlike forced inhalation volume, with forced exhalation volume, you'll always still get a little bit of residual volume left at the bottom. So the total lung capacity is going to be all of these combined. So just to recap spirometers. So spirometers, you are linked up to a piece of machinery that's going to measure the amount of gas in your lungs at any moment. And it does this by having an airtight chamber filled with oxygen, measuring a water level around the outside, which is connected to a trace. And then the final thing you need to remember is that there is a canister of soda lime to remove the carbon dioxide being produced, because we only want to look at the amount of oxygen. We can then measure a few different things. So firstly, the vital capacity. This is the maximum volume of air that can be inhaled or exhaled in a single breath. You can see that on the graph here by the top to bottom amount of lung volume. The tidal volumes, this is the volume of air we breathe in and out at each rest. So this is the regular breathing seen at the beginning of the trace, which is relatively small, not very varied and regular. The breathing rate, so this is the number of breaths per minute, which can be calculated from the spirometer trace by counting the number of peaks or trough. So in this graph, for example, if the graph was labelled, so say for example in the first half of the graph, before a deeper breath is taken, that you was to say that was 1 minute, you would count the number of peaks as 1, 2, 3, 4, 5, 6, 7, 8, 9, and say that there are 9 breaths per minute. But then there's also a residual volume left in the lungs, both on inhalation and exhalation. So you can see on the graph a forced inhalation volume increases the peak of the breath, and that is referred to as our vital capacity, where you have your tidal volume plus the forced inhalation and forced exhalation volume, but then you still have an extra residual volume at the bottom from exhalation, and so the forced inhalation, forced exhalation, vital capacity plus residual volume all equal to the total lung capacity. So that is the total amount of air that can be stored at the lungs at the same time, which would never be able to be measured on a spirometer because your lungs are never going to be without air. So now just putting this all together as a recap. So if you look, I want you to imagine what is going on in terms of the intercostal muscles and the diaphragm at each inhalation and expiration when you look at these peaks going in and out. So inhalation, the peak is going up, we're breathing in, air has reached our alveoli, the external intercostal muscles contract, the internal intercostal muscles relax, and as a result, this causes the ribs to raise up and out. The diaphragm contracts and flattens and therefore lowers. This causes the volume inside the thorax to increase, lowering the pressure. The difference between the pressure inside the lungs and the atmospheric pressure creates a gradient, causing the air to be forced inside the lungs. Now we're going to look at expiration. So when this graph, the line of the graph and the spirometer readings coming down. So here the intercostal muscles contract, whereas the external muscles relax. Therefore, the rib cage lowers back down. The diaphragm relaxes and also moves upwards. This action, in combination with a decrease in the volume inside the thorax, therefore increases the pressure and forces air out of the lungs. So the lesson today is a little bit shorter, but I am going to cut it there because I do not want to move on yet to circulation, which is what I'm going to cover in my next lesson. But the last two lessons have been pretty heavy ones. You may want to listen to them more than once. And Lauren will be back next week with gas exchange in plants. As ever, I recommend that you listen to my follow-up revision lessons, which are available over on Patreon. So thank you so much for listening. Remember, you can access additional content on our Patreon page by searching for Equity Tutors, where we have a second 30-minute lesson every week, plus monthly bonus content. You can also find us on most social media platforms. We will keep you updated on new content, and you can find us there by searching for Equity Tutors UK. Please like, share, subscribe and comment wherever you are listening, and if you're enjoying, please leave a review. Bye!
Bye!